try to get as direct as you can. That looks good. Today this is the second lecture in evaluating common angles, and we're going to look at angles greater than 90 degrees. Last time we just looked at 0, 30, 45, 60, and 90. And now we're going to look at 150 degrees. Well, how in the world do we do this? I mean, how do you drop an altitude down to the initial side? And we have several steps in doing this. And the first step is we superimpose the Cartesian coordinate system over our angle like this. And we call this the x-axis. And we call this, of course, the y-axis. All right? And the x-axis continues out this way. All right, so I've superimposed the Cartesian coordinate system over my angle right here at the vertex and as the origin. And now I can drop an altitude to the x-axis. Don't drop an altitude to the y-axis. Always drop the altitude to the x-axis, no matter where you are. Remember that. I drop it down here like this. And now I have what I call a reference angle. I'm going to call that theta reference. If this is theta, then its reference angle is this smaller angle here, which we can accommodate fairly easily, especially if it's a common angle. And I see that if this is 150 degrees all the way to here is 180, so our reference angle is clearly 30 degrees. With this caveat, notice this side is going up this direction in a positive direction on y, so it's a positive number, and this would be positive 1. But we're going, this directed distance is negative, right? And if we consider that the hypotenuse is always positive, and this is negative square root of 3. Now let me repeat that again. We look at this side and we see that it's going up and it's a positive y value if we go up to the point at the end of the terminal side. If we go this way, this is going to be a negative value. Remember, this is a 30-degree, 60-degree triangle, so this is 1, 2, square root of 3. We always consider this to be positive in any of our angles. So this one's negative and this one's positive. Now when I want to find the cosine, I remember that it is cosody adjacent over hypotenuse, so it's negative root 3 over 2. Notice in absolute value it's the same as the cosine in 30 degrees, but in this case it's negative. If I were going to do the sine, it would be positive 1 over 2, and that would be a positive 1/2, the same as 30 degrees. Okay? And you can figure out the rest of them from these. Another way to do it is you can turn this thing around and say, okay, here's my triangle. It's 30 degrees. Okay, I'm going to call this negative root 3. I'm going to call this positive 1. I'm going to call this positive 2. I can do the sine, cosine, tangent, and some of them will be positive and some of them will be negative. Okay, let's go over here and look at another angle here. This is an angle of 225 degrees, and we're going to find the tangent of 225 degrees. And the way we do that is superimpose the Cartesian coordinate system over our angle like this and like this. And I have a y here and I have an x here. And I drop my altitude, again, not to the y-axis, but always to the x-axis. And then I work with this smaller angle, okay? And what is that smaller angle? Well, it's 225. That's 45 more than a 180. So this is a 45-degree reference angle, which means, yes, I can find the tangent or the sine or the cosine or any other trig function of this angle. But I realize that this distance here, and I've kind of not drawn it very well, because what is it? It's normally 1, 1, square root of 2, right? I should have made it look a little nicer. But I've got this is a negative direction, and this is a negative direction down here. This is going negative going down, it's going negative, and the y-axis gives me a negative value, and here it's a negative x value. So I consider it as both of those negatives, so I could redraw my 45, 45, 90 triangle like this, only now this is negative 1, square root of 2. We always consider the hypotenuse, or the terminal side, to be positive, and these can be either positive or negative, going in a negative direction, going in a negative direction here. So now I can find sine, cosine, tangent. If I wanted to find the sine, it would be negative 1 over the square root of 2, but I want the tangent here, and that would be tanipad, opposite over adjacent, negative 1 over negative 1, which is a positive 1 right there. Okay, and now we'll do one more over here. We'll do the sine of 300 degrees. I know the sine of, I know. Okay, again, it's the same deal. I superimpose the Cartesian coordinate system over the angle like this. I call this the x-axis. I call this the y-axis, all right? And I drop my altitude, again, always toward the x-axis. And then we can work with a smaller angle here, the reference angles we call it. So theta reference here is, well, 300 degrees, that's 60 degrees shy of 360s all the way. So this is 60 degrees. So this has to be 60 degrees. You have to have a little bit of savvy in angles to find these. Now, if this had been 65 degrees, we would have had to resort to our calculator. But it's not, it's 60 degrees. So it is a common angle. And I noticed that the x value, what is it? So 1, 2, square root of 3. Right? Hope I've got that right. Let me think. Yeah, it's one. Yeah, it's the shorter side, twice longer. Okay. And I didn't draw them really. I should have spent a little more time drawing. It would look like more like a shorter side. But that's the way it goes. But I noticed this is positive 1, and I know this is a negative. It goes down this way, negative on the y-axis. In this direction where the y-axis is negative, so it's a negative square root of 3. And if I like, just to clarify it, I can redraw the triangle the way a little better, and this is 60 degrees, and this is positive 1, positive 2, the hypotenuse is always positive, and negative root 3. Now if I want sine, if I want sine, it is synopy, opposite over hypotenuse, that's negative root 3 over 2. And that's the sine of 300 degrees.